All right, 9.4, the tangent ratio. So starting off, we have a trigonometric ratio. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. All right triangles with a given acute angle are similar by the angle-angle similarity theorem. So what they're saying is that if you have two right triangles here, right, there's one angle listed, and if I tell you that maybe this is like a 37-degree angle, then now you know those are similar triangles, right? You know nothing else, but you know that they're similar triangles. Now what these trig ratios do are they use similar triangles in a way that you could find a missing piece really easily. With these trig ratios, they take a single triangle, maybe it's the 37-degree triangle, and they find the ratios of all the sides. And your calculator has that stored in it, so that next time, whenever you find a different triangle, maybe now you're on this green triangle here, you can pull up those ratios from your calculator again. So, right, if you have a calculator in front of you, you could type in, we're going to use tangent today. There's a tan button on there. It says TAN. And then if you type in the number 37, it should give you a decimal that's like 0.75. It has a little bit more than that, but that's the gist of that. What that's telling you is the ratio of two of the sides. If you take one of the sides and divide it by the other one, you're going to get 0.75. And we can use that to kind of generalize on a bunch of different triangles there. So if that didn't make sense, that's okay. We're going to go on and hopefully it makes more sense later. Let's look at this. This piece right here I think is too wordy, so I'm just going to skip over that. The tangent ratio, that's the one that we're using, is a ratio for acute angles, right? That matters. We don't look at the right angle. We look at one of the two acute angles. That involves the lengths of the legs of the right triangle. Okay, so we're looking at the legs. We do not care about the hypotenuse today. So the tangent ratio. We always look at it from a perspective of an angle. So this one says tangent of A. So we're looking as if we're standing at A. And we care about opposite and adjacent. Well, opposite means opposite, far away. So opposite is always farther away from A. So there's the opposite leg. And adjacent means next to. So we have adjacent, that's touching A. It's right next to A. So I told you that this 0.75 is a ratio of the legs. What it is, in this triangle, if this was a 37-degree angle, and there's nothing really special about 37, it's just the number that I picked. That would be like you took this opposite leg divided by the adjacent leg, talking about the lengths of them, and it would give you 0.75, or whatever it would be if you had a different degree there. So if the opposite was 5 and the adjacent was, I don't know, 6, then the tangent would be 5 over 6. Let's look at this as an actual example here. Example 17, find tangent of S and tangent of R. So we start off with tangent of S. Well, from the perspective of S, this would be the opposite and this would be the adjacent. So it would be 16 over 12, which we can reduce to, what would that be, 8/6, 8 over 6, which would be 4/3. We also want to write that as a decimal, just because it says that we're going to do that. This would be 1.3 repeating. Now I'm going to erase my opposite and adjacent symbols, and I'm going to say tangent of R. So now from the perspective of R, 12 is the opposite and 16 is the adjacent. So it would be 12 over 16, which would reduce to 3 over 4, which is 0.75. Notice here that these are reciprocals of each other. Okay, that's always going to be the way that tangent works. If you take the both angles and find the tangents, they're going to be reciprocals of each other. Now let's look at 18. So now we're actually going to find a side length. So right here, we're obviously looking from the perspective of 35 because that's the one that's marked. So we're going to say tangent of 35 degrees equals opposite 12 over adjacent x. Now, if you type in tangent of 35, it would give you 0.70 blah, blah, blah. Now, before I type that in, though, I want to get my x alone because whenever you type in tangent of 35, it's a really long decimal. I don't want to round in the middle of the problem because I'm going to have to round in order to write it down. I don't want to round in the middle of the problem. I want to round at the very end of the problem. So I'm going to solve for x, and I'm going to treat this tangent of 35 as just a single number, okay, because that's what it is. It is a number. So I'm going to multiply everything by x, so x goes on the left. X times tangent of 35 is 12. And then now I can still treat tangent as if it's just a plain old number, because that's what it is. I'm going to divide by tangent of 35, and I should have my little degree symbol there. X equals 12 divided by tangent of 35. Really, I should write that T in cursive so it doesn't look like a plus. There we are. Now I'm going to type in my calculator. 12 divided by tangent 35, enter, and I got 17.14. That's our x. So what we did here is this tangent of 35 is kind of like a proportion, right? Think about whenever we had similar triangles, we would say something like A over B equals C over D. We'd have some kind of proportion. What we did here is we said, well, A over B, we're just going to say that this is our tangent. And then we have 12 over x, right? And instead of saying we have the nice proportion where it's a fraction, we took and we divided the A and the B, and we got something like 0.75, or 70, excuse me. Okay, so that's what we're doing here. And if you still don't really see how we're using similar triangles there, that's okay. You don't have to necessarily see that. You just have to know how to use the tangent. But I think it is valuable to be able to see that, right? We are still using a proportion, or we're kind of using a proportion, but it's kind of hidden in there. All right, let's scroll down and look at number 19. Find the tangents of the acute angles of each right triangle, write each as a fraction and then as a decimal. So this is back to like what we did in example 17. So the left side here, we're going to have two different tangent ratios. We're going to have one for each of the acute angles. We'll start off with S. Well, tangent of S is opposite over adjacent, 10 over 24, which is 5 over 12. 5 divided by 12 is 0.416 repeating. Now we look at it from the other perspective of the R. So tangent of R is opposite 12 over adjacent 10, which is, opposite 12 over, excuse me, I didn't write that correctly. 24 over 10, which is 12 over 5. And then whenever I take 12 divided by 5, I get 2.4. All right. Next up here, we have tangent of F, opposite 8 over adjacent 10, which is 4 over 5, which is 0.8. Then we have tangent of G, 10 over 8, which is 5/4, which is, what is that, 1.25. All right, hopefully that's not too crazy. Let's look at example 20. All right, we're almost done here. Find the value of x for each triangle. So we're looking from the perspective of the 70. X is opposite and 30 is adjacent. So we can say tangent of 70 is x over 3. Before we even type in tangent of 70, we know that's going to be some kind of ugly decimal, or it's probably going to be an ugly decimal. I want to get my x alone, that way I'm not going to have to round in the middle of the problem, that way I round at the end of the problem. So I'm going to multiply by 3 on both sides to get 3 tangent of 70 is x. Now I can type this in my calculator. 3 times tangent, or just in my calculator, I can just type 3 and then go straight to the tangent, and it knows that's supposed to be multiplication. So 3 tangent 70, and I get 8.24. There we are. Next up, again from the perspective of the 40, so tangent of 40, 15 is opposite, x is adjacent, so 15 over x. Solving for the x is going to be x equals 15 over tangent of 40. Okay. If you're not able to see the algebra that I did there, think about it as if I had like, well, let's do a different number. 7 equals 5 over x. I can solve for that, and it would be x equals 5 over 7, right? I'm doing the same algebra there as I did with the tangent. To get x by itself, 15 divided by tangent 40 gives me 17.88. All right, that is section 4.